Hey everybody, my name is Nick. I'm a solutions engineer here at Panther. I've been here for about 2.5 months. Before this, I worked at Duo Security for about 4.5 years. And with me is Jason. I'll let him introduce himself.
Hey everyone, name is Jason Zandona. Been here with Panther for since March as a solution engineer. Before that, I was about 8 years working as a security analyst, engineer, architecture, kind of wearing all the security hats for a EDA company in the Bay Area.
Cool. So what we want to talk about today is Panther's mission and a little bit of an overview of what Panther is. We wanted to talk through Panther's architecture, including how we do data ingestion, how we do detections, and how we triage those detections. And what we'd like to do as well is show you this through like a real world demo using Okta. And then after that, we'll handle some Q&A and conclude. So Panther was founded in 2018 by a team of security practitioners who experienced the challenges of threat detection and response firsthand. They set out to build a platform designed specifically to overcome those challenges. You can think of Panther in 3 main pillars: cloud scale, security, data lake, and detections as code. And what we mean by cloud scale is our architecture is totally serverless and built for massive cloud scale. With Panther, security teams don't need to think about the overhead of scaling a system to deal with more log volume. The security data lake is, again, a serverless architecture, and we separate storage from compute. So security data can be stored cost effectively with the ability to query terabytes of data in minutes, not hours or days. And again, that's with 0 operational overhead. And then detections as code, we allow security teams to create high fidelity detections with Python. And you may also leverage your current CI/CD workflows to automate that process, include testing to your rules that you create, and harden those detections as well. This slide's a little bit busy, I'll admit, but what we want you to get from this is we want you to collect and store all of your data so you can get the whole picture of what's going on in your security or over your security. And we want you to focus on building those security efforts rather than dealing with infrastructure. And we want to make sure that you analyze logs as they're ingested versus querying for threats in the past. Of course, we give you the ability to query for data over terabytes of data within minutes, not hours or days. And then again, we use Python to pull out detections or pull out information that you're interested in alerting your teams about. So here's what Panther looks like end to end. On the left-hand side, you can see a variety of data sources, including cloud infrastructure logs, SaaS applications. We can ingest custom log sources as well if you don't see an application here that you guys use in your environment. And with the data sources that we have out of the box, we include over 150 detections when an instance of Panther is stood up. So as we go through the process of onboarding a data source, we then parse and normalize that data into a standard format. We use JSON. And then 2 things happen. We store a copy of that raw event into Snowflake, and we also run that event through our detection engine, where you use Python to pull out the information that your security team is interested in. If a detection matches, we'll also store a copy of that match in Snowflake as well in a separate table. So that gives you the ability to search for the raw event and the event that matches if you needed to do further investigation in the future. After It goes through parsing and normalizing and the detection engine. If a detection fires, we have the ability to send an alert to an incident management system or an incident orchestration system. We're going to demonstrate what it looks like when a alert is fired over Slack. But we have customers using, Teams, Jira, PagerDuty. You can send it to Times. We have a custom webhook as well. And then additionally, you can hook up the data lake to a custom visualization tool. So if your team uses Tableau or Mode or Snowsight or something like that, you can build visualizations out of the data that you ingest into Panther. So Jason, what do you see as the most popular way customers are ingesting data?
Sure. So customers will usually use one of our native API pullers, say pulling data directly from the Okta API, which we'll demo here in a bit. But other native API pullers we have, Duo and a few others. If the data is not being pulled directly into Panther, most use cases or most customers will leverage S3. So if you can get the data to S3, we can pull that data in from the S3 bucket, read those events, those objects into Panther, and move down that pipeline of parsing, normalize, and running them through the Python detections. We also have some flexibility around using an SQSQ, as well as being able to parse out Amazon CloudWatch log groups. So if you have data going to CloudWatch log group, you're able to dump that to, I believe the flow is Firehose, into S3, that Panther can then again read that data in.
Awesome. And can you tell me a little bit about how we would onboard custom data from like an on-premise or a legacy application?
Sure. So Panther, of course, supports, we have parsers for some of the integrations that we show here, or all the integrations that we show here. And we have a longer list of integrations on our website than what we have on this slide. But for any data sources that we do not have a native parser or a native schema for, we can create, or the customer can create, a custom schema. For on-prem data sources, say maybe a large data center environment has Palo Alto network firewalls or checkpoint firewalls or something like that. As long as you can get that to the events to S3, we can read it into Panther. The way, kind of how that pipeline looks, customers usually find a lot of success using FluentD, an open source agent, to use the S3 output of FluentD to get the data from wherever it's being stored up into S3. Another agent customers find a lot of success using lately is Cribble to handle that data pipelining and export to S3.
Awesome. Yeah, that's super helpful to know. Thank you. So moving on here, what I wanted to show you guys next is a little bit more, if I go back a second, for this parsing and normalize section. What that actually looks like is on the left-hand side, you can see a raw log example. It can be in really any kind of format. And what Panther is doing in that section of parsing and normalizing is we're turning it into JSON format so that when we use Python to create our rules or detections, it's easily findable instead of having to worry about regex or like a CSV format or anything like that. And we're also normalizing it and adding additional fields, those plog, pne type fields as well. So then the whole picture looks like this. We have the parse log. There's an example rule here, which we're going to get into when we jump into the Panther admin panel. And then on the right-hand side is an example of a Slack alert. And then this is a sneak peek into our data explorer feature on the right-hand side and our indicator search on the left-hand side. Data Explorer allows you to query for any of the data in Snowflake using SQL that you ingest through Panther. And then the indicator search is a tool that you can leverage to search for an indicator of compromise, like an IP address or a username or an MD5 hash or something like that, and search for it across all of your logs. And again, we're going to show you what that looks like in the demo. So using Okta, what we'd like to show you is a couple built-in detections that we have. What it looks like when somebody creates or revokes an API key within Okta. When somebody creates a new admin role within Okta and what that alert looks like, and then what a custom alert might look like that you could use within Panther. In this example is letting your security team know anytime somebody uses SMS and maybe asking them to update into a more secure MFA method like YubiKey or a push notification or something like that. So with that, let me break out of the slide deck here, bounce over to the Panther admin panel. On the left-hand side, this is just my Slack window. As I onboard Okta as a log source, we're hoping we can show you some live events come through. So let me go over to integrations, log sources. I'll add a new log source. Again, Panther supports a number of SaaS services and cloud infrastructure applications out of the box. We're going to focus on Okta. We'll start the source setup. We'll give it a name, dev webinar Nick. Let me grab my host name here. Okta domain is okta.com. We support Okta Preview as well. Let me grab my API token, paste that in, continue setup. Panther's making sure that we can establish a connection to Okta here. And we can also set an alarm that would fire if Okta does not send Panther any data for a day or an hour or whatever interval you choose here. I'll leave that as the default. And then this is letting us know that by default, this will send alerts or alarms to this Slack environment that I have up on the left-hand side here. So let me finish that setup. We can see that we haven't received any data yet. So it usually takes about a minute or two for the API to communicate with us. So let's bounce over to detections. I'll open up a new tab because I have these detections filtered by Okta specifically here. And let's talk through an API token created first. So let me edit this rule and we can talk through this. Each rule contains settings. You can you can let it know if it's enabled or disabled, what severity level each alert will fire as the default. In this case, it's just low. What log type this is correlated to. You can enter multiple log types here if you wanted to, if it was a more generic rule, or if you wanted to check for API tokens across not just Okta, but maybe G Suite or AWS or something like that. You could use one rule for many log sources there. We can give it a name, a description, a runbook which we think of as just what to do if this actually happens, and a number of other settings here too that we'll touch on in other rules. But we can go over to the functions and tests tab here, and this is just a bit of Python that we're using to fire an alert if it detects these fields. So the definition rule here is looking for an event type. And if that event type is system.api token create, and the result of that event is a successful one, then we'll fire an alert. We also define a title function here that will create a dynamic title when the alert fires. So we also include some context with the alert that gets fired off. And we include the ability to do unit testing right here within the UI. So this is just a piece of JSON that includes the event type that we're looking for, the API token create, and the outcome result is a successful one. So should this test event trigger an alert, yes, it should. And when I run a test, we can see that this will pass. And the alert title is test user at example.com, created a new API key. So Jason, another question for you. Do I need to manage these rules and detections within the UI here, or are there other means that we provide to customers?
So the managing the detections in the UI, it's nice and easy to test or use test cases against your detections as you're writing them. However, kind of the detections as code piece of Panther is all of these detections that we have out of the box are open on are available on our open repository on GitHub, our Panther analysis repository. So if you flip over to that, if you dive into one of these detections, these rules, there is a Python file and a YAML file that make up a detection. Python file is the Python logic. The YAML file is the kind of the metadata of what the rule is, the name, the severity, the destinations, and also those test cases. What most customers will do, they will actually fork down this public repository, make their customizations for detections, create their own detections, and Panther provides a CLI tool to run tests, those test cases against the Python logic, and upload into Panther once those tests are working. So back to the customer scenario, customer will fork down the repository, make their edits, test, and push up into Panther which builds out this detection of the code, revision history, easy way to fall back on past detections or past versions of detections, and have some auditability to track changes.
Yeah, I've seen customers use GitHub Actions, Circle CI, Jenkins, really any kind of CI/CD tool, right?
Yep.
Cool.
Agreed.
So let's jump back over to another rule here. We'll do the admin role assigned. This is just checking for if a user's been granted admin privileges. This will only fire off if we detect that it's happened more than once every 15 minutes. The deduplication period and threshold is customizable. So in another example, like a brute force login attempt, if somebody was trying to log in 10 times within 15 minutes, then we would fire an alert. We wouldn't fire 15 alerts or 10 alerts. We would fire one alert that includes all 10 or 15 events within it. So we're not trying to be super noisy. We're trying to give you guys the flexibility to alert on what matters and include an importance level of how critical that issue is. So looking at the code for this one, this is importing regex, and that's just so that we can detect if the administrator is lowercase or capitalized. Similar to the last rule, it's looking for another event type of user account privileges grant, and if that result was successful. And additionally, if the admin pattern here was found within privileged granted in the event. There's a dedupe function here, a title function, just like in the last one. Here's our JSON for the test. Of course, we can see the legacy event type and the event type here and the result. So when I edit this rule and I drill down and run my test, of course, we would expect to see a pass that says, Jack was granted these privileges to Alice Green.
Nick, I think there might be a typo in that title. Should be probably Jack granted instead of
yeah, he was.
Jack was.
He was granted. Let's edit that. So we can just erase was there within the title function. It's returning the display name, granted these privileges to the alternate ID. So let me update this. Let that save. We'll come back down. We'll run this test again. And there we go. Jack granted privileges to Alice Green. That makes more sense. Good call out.
And Nick,
Thanks, Jason.
One more thing to point out here: the test case that Nick is running the test with, that's the actual event that would have passed through Panther and being tested against this Python logic. Yep. Panther is a fully serverless architecture, so as the events are being read in, say from S3, or maybe in this scenario through the Okta API. So as the events are being pulled down from the Okta API, the events are on the back end being checked against the Python that are Lambda spinning up and checking to see if there's a match. So building out test cases for different scenarios or edge cases is very powerful here. We've seen customers use, if there's a false positive, they will take the event from the false positive that triggered and then put it in as a test case and then edit their Python logic to build build out of that false positive event.
Right. Yeah, you can have as many tests here as you'd like. Typically what we would do is have one that is successful and should fire an alert, and then one that is just a log that wouldn't fire an alert, or we wouldn't expect to fire an alert. But in this case, we just have the one. Cool. So there's a few notifications here that we've already received. So it looks like Jason granted super administrator privileges to Clark Kent. And then there's some context here. We can actually click to view this, and it opened in the wrong tab. Excuse me 1 second. Let me bring this over here so you guys can see it too. Oh, I'm not even logged in. Jeez. This opened in my actual browser window. Let me sign in so we can see this. And here we go. So Jason was granted super administrator privileges to Clark Kent. We can see the details that we defined in the rule. We can see the summary attributes as well. And these are for the 4 events. And then if we wanted to see the raw log, we have it available to us here within the events tab. And similar to what Jason was just mentioning, I could copy this JSON and use it within the rule when I create my unit tests. So I could build those those test cases pretty rapidly as things are coming in. Or if I wanted to go to the data explorer and view the data first, I could view each event and grab the JSON from there. There's one more rule that I wanted to show you guys before we drill into the data explorer and the indicator search first, and that was the SMS or users using SMS for MFA. So all this rule is doing is it's looking for this legacy event type, which Okta uses SMS is a legacy or a more legacy MFA method, and it's I assume part of their legacy API, which is why it says legacy event type. And when an SMS message is fired within the API, it has this message, core user SMS message sent factor. So I can build a title again where the actor display name is using SMS if event.get legacy event type is equal to this, will return true. So let me go back to edit my rule so that I can run my tests. And when I run my tests, we can see Clark Kent is using SMS for MFA. And we were hinting at this a little bit earlier. You can see there's a number of other functions you have available to you in the rule. Jason, could you outline some of these for us?
Sure. So yeah, so with the detections in Python, we provide a few functions and you can create your own functions but a couple of functions of when an alert is triggered. You can dynamically update certain metadata. So on line 18, severity, you can update the severity on the fly depending on your Python logic. So if you have a list of C-level executives that you're wanting to monitor more closely, or maybe privileged access or privileged users that have more access than I guess powerful users in your environment, and you wanted to monitor those. If those users triggered an alert off of a detection, you can update this severity from, say, a medium to a critical or a high. You can do the same with destinations. So depending on the scenario, depending on what you're wanting to accomplish, you'd be able to update what destination this alert would fire off to, or multiple destinations, dependent on, again, on your scenario. The alert context at the bottom there, this is a function that you can build out your own dictionary to send data off to the next destination. So it be Jira, Tines, Hive. You're able to add context to the alert and pass that along with the alert.
Awesome. Yeah, and then you could use, Panther to ingest the data, parse it, analyze it, fire detection, and then Tines would take it from there and automate either the corrective action or, something along those lines, right, is what you're saying?
Yep, that's
cool. Then the other thing, that you could do related to this rule and using these severity functions and destinations is, if a user was using SMS, that's one thing. We could take that severity level for that action and send it to high. But if somebody was using a push notification or YubiKey, you could take that action and still alert on it, but make it like a low or maybe like an info level, so that your team isn't bogged down by it, but you can go back and build those reports that we mentioned earlier on with the visualization tools and things like that. You could additionally send each of those unique actions to a specific destination too. In this example, we just have Slack hooked up, but you could hook up a number of different destinations, and depending on what happens, fire it off to the respective place. Cool. So if we go back to this rule, there's a number of places you could see the rule as well. So as they come in, we could always view them in Slack and see that an API token came through. But we could also jump over to rule matches, and we can see, using SMS for MFA. Bruce Wayne is using SMS for MFA. We can go and inspect this. We could jump into the events again. And we could view this data within the Data Explorer with this button up here on the right-hand side. Let's just open that guy up. What this will do is it'll generate the snippet of SQL that we need to go and find this query, or for this event in the Data Explorer. We could narrow this down and find all of the logs, or at least the last 100, if we did a limit of 100. But additionally, from here, as you view this JSON, you could jump in and say, this event doesn't actually have what I'm looking for. If I go back to the event that actually fired when SMS was being used for MFA, any of these indicators of compromise, we can open up in the indicator search. And what it'll do is search for that IP address across all of our logs within Panther. In this demo environment, we have Okta hooked up a couple of times. So we see that same IP address from our tests show up in multiple logs. But I hope this gives you guys a visualization of if I had my CloudTrail logs hooked up, if I had my G Suite logs hooked up, if I had all of the data flowing through Python or flowing through Panther, we could maybe see this IP address come through on other services that somebody might be attacking us on. So then I could click into these logs here, and it'll take us back to the Data Explorer again, and we can continue our search. So cool. Let me go back to the slide deck here, pull this up. So what we just showed you is, how easy it is to hook up to the Panther. A few detections that we created and some data streaming through there, including the API key, the admin role, the signing, and SMS for MFA, those alerts firing off to Slack, and a little bit about how you could triage those alerts. And Panther is loved by cloud-first security teams.
So Nick, why are we loved? I guess I can help answer some of that question. As you guys saw with Python, using SQL to search the data, using Python to write detections, streaming detections as the data is coming through. Panther is trying to provide a lot of flexibility in common languages. Instead of using some proprietary query language or having to write detections off of historical data, we're trying to create a developer workflow in a scalable manner. We mentioned it a couple of times that Panther is serverless architecture. We're running at cloud scale. We have customers doing north of 300 terabytes a month. It has been stress tested much higher than that. And if you were to be ingesting, say, 10 gigs a day, and then decided the next day, start ingesting a terabyte worth of data a day, you do not see any performance degradation or impact on your queries or your Python detections because of the serverless architecture. So on the back end, Panther scales up, as well as the data store Snowflake scales out as needed.
Awesome. Yeah, thanks for that insight, Jason. You answered that better than I could have. So yeah, let me go back to here. So we want you to do more with your demo, or with your data. Included here is just a little video. Why are you not playing? Unable to play video. Let's try that again. This video is just like a little scroll through.
Yeah. My guess is an incognito window is screwing it up. So what this video was is, pull up the.
Yeah, it's just a scroll through of our integrations page, which is here, panther.io/integrations. Similar to the log sources button that when we onboarded Okta that you were looking at, just outlines a bunch of different resources that we have built into Panther. So with that, there's some questions that have come through in Q&A that I'm seeing. Jason, I think you've already touched on the first one a little bit. Why do we use Python for detection creation? It's a common language. It's easy to use. It's easy to read. It's easy to understand. It's highly popular. I believe that's why we standardized on that one.
And highly flexible. So Panther comes out of the box with all the standard libraries that Python would install with. We also have requests library and a few other libraries. It's very easy to add in another library or module. We have customers that have beautiful soup in their environment. or in their Panther environment, so they can web scrape directly from the Python detections, depending on their scenario that they're trying, or their workflow that they're trying to go down. I mentioned requests. We have customers making request calls out to different endpoints to either do some enrichment or some other checks. That's a very popular one. And being able to store all of these detections in your repository for change management, for code management, has been extremely popular and powerful for our customers.
Yeah, totally. And hopefully you can help us answer this next question too. Would we consider Panther to be a true XDR? And how easy is it to add new data sources?
So Panther is, as long as Panther is able to see, or as long as the data is in the logs, Panther is able to do something with that data. How easy is it to add new data sources? Very easy. New data sources, just needing to create a custom schema, which are written in YAML. We support regular text log, like syslog style events or logs. They get able to be parsed in with fastmatch or regex. If it's a CSV style log, we can ingest that as well. If it's JSON, we can infer that into a schema and ingest that as well. So we do have a lot of flexibility on what type of log types we can pull in. And then if there's, every once in a while we come across a very difficult log type, we can do some pre-processing of the data with like Fluent D agent to get it into a JSON format and then ingest into Panther.
Yep. We have a command line tool available to us as well that will infer schema as well, right? If you have a log file, we can use this tool to do its best to infer the schema without any pre-processing or anything like that as well, assuming it's in a format that we can read.
Yeah, we have a Panther log. It's called Panther log utility that helps test out these schemas, test them against data or events before having to kind of test it out live in Panther. So kind of a lot of the theme is being able to do all your testing outside of Panther before moving it into kind of a production state or a live state. I see another question here. Can you create a real-time rule for Okta to alert on a threshold of failed authentications in the last, say, 10 minutes?
Yeah, you can. We didn't demonstrate it. It's one of our built-in ones. We call it brute force logins. It uses that deduplication period that we briefly mentioned, where, you know, if this event happens 5 times within the last 15 minutes, then we'll fire an alert. And that's to say, if somebody's trying to log in and has the wrong password rapidly, we'll fire an alert, and you can set that at whatever severity level you'd like, anywhere from info level to critical.
And I see another question that's I'd love to answer. So how easy is it to create alert correlation across different sources? There's a few ways we can do this here. So in the Python logic, you're able to access DynamoDB database from that logic. So you're able to cache events and then pull events from cache and check against if you'd like to continue on alerting. That is one way of using kind of like a stateful cache of events coming through Panther. Another way would be, we didn't demo it here, but in the Data Explorer, we're able to save SQL queries. You're also able to schedule queries. You're able to schedule saved queries to run, say, once a minute, once every day, something like that. And within the SQL itself, you're able to join multiple tables or all your tables together if you'd like, and map them together and pull out results from that query from multiple data sources. So you can get pretty complex on the SQL side, or actually very complex on the SQL side. And as those scheduled queries run, the results can be pushed back through the Python detection logic. And you could have Python to continue on with your either just send it off straight to an alert and destination, or using that Python logic to do some more manipulating or slicing, dicing of the data to determine if you want to an alert.
Yep, and I was just trying to show you guys on the screen. I was on this rule for quite some time. This is just an example rule of Okta's, or a rule that we created to detect geographically improbable Okta logins. And this rule uses some of those DynamoDB features that Jason was just mentioning. And then
Cool.
Within the Data Explorer, saving a scheduled query that we can run additional rules against as well.
Yeah, thanks for diving back in there.
Yeah, no worries. There's
I got to go ahead.
I was just gonna say, it looks like there's 2 more questions. How many rules does Panther come with to start? We ship with over 150 of them out of the box. If I bounce back into the browser, this analysis repo is open source. You can feel free to browse through any of them at any time. Also, there was a link in the chat that Emily shared to go through the integrations as well. The other question was, what are the main reasons your customers have purchased Panther? Jason, do you want to answer that one?
Sure. So some of the main reasons, I did touch on it a little bit, but flexibility, common languages, as well as real scalability. We don't want our customers to have to decide if they want to bring in CrowdStrike FDR logs because of, they have 20,000 agents and it's just too much for some of the other vendors out there, and bog down their systems, the performance degrades, and the licensing cost skyrockets. We don't want any of those type of conversations or any of those customers having to make that decision of not bringing in certain data types because it might be too much volume. Ship it into Panther. Panther scales up just fine, and be able to write real-time detections on the logs being ingested through Panther.
Awesome. Thanks for answering that, Jason. It definitely makes sense to me. So yeah, thanks everybody for joining the call today. I really appreciate it. I hope you learned a lot about Panther. Please let us know if you have any other questions.